going to do it where we don't actually graph anything in the calculator, but I am going to use the calculator for just calculation purposes, but not graphing purposes. So I wanted to show you something from what we did the other day. And I wanted you to notice that whatever the axis of symmetry is, that's always the x-coordinate to your vertex. So of all the problems that we've done in the last few days, I could show this to you for every problem that we did. But whatever you get for the axis of symmetry, that's always the x-coordinate to your vertex. And the reason is because your axis of symmetry always runs through your vertex. So does it make sense that the axis of symmetry has the same x value as the vertex because it runs through it? So when we graph today, the first thing we're going to do is we're going to find the axis of symmetry, and we have a special formula for doing that. But when we get the axis of symmetry, we'll also know the x-coordinate to the vertex, and then we'll just go from there. Okay? So it's like killing two birds with one stone. Are you ready? Let's do it. All right. First thing we're going to do is we're going to find our axis of symmetry, and we're going to use this formula right here, opposite of b over 2 times a. And then I'll just kind of explain everything as we go through. I could read all this to you, or you can read it on your own, but I just decided we'll just work it. Okay, so coming down here, I do want to remind you that a is the number in front of the x squared. So in this problem, my a is a 1. B is the number in front of the x. So in this problem, b is a negative 2. And then c is the constant, so c is a negative 3. Just in case anybody forgot where a, b, and c are. Okay, so first thing we're going to do is we're going to find our axis of symmetry, and I want to see if we can do some of this in our heads. So this wants us to take the opposite of b. So what would the opposite of b become? A positive 2. And then let's see if we can do 2 times a in our head. A is a 1, so what would 2 times a give us? What would 2 times a give us? 2. And then what's 2 divided by 2? 1. All right, our axis of symmetry is x equals 1. So the first thing I'm going to do is I'm going to draw my axis of symmetry. I'm going to come over to where my x is a 1, and I'm going to draw myself a dashed vertical line. And that is going to split my parabola in half. Now, one thing I haven't mentioned to you in the last few days is whether a parabola opens up or down. Does anybody know from your past? Do you know what this parabola is going to do? Can you tell if he's going to open up or down? It's going to open up. If a is a positive number, your parabola will open up. If a is a negative number, your parabola will open down. Do you remember ever learning that? You should have, but if you didn't, it's no big deal. So if a is a positive number, the parabola opens up, and if a is a negative number, the parabola opens down. Okay, so after we find our axis of symmetry, the next thing we're going to do is we're going to find our vertex, and we already know something about the vertex. Remember, whatever the axis of symmetry is, that's going to be the x-coordinate to the vertex. So I know the x-coordinate's a 1. So whatever you get for your axis of symmetry, that's always the x-coordinate to your vertex. Now, use a little common sense here. I know the x is 1. I need to know the y. If your x is 1, where do you think you might put that in this problem? If this is your x, where do you think you might put that in the problem? In all the x's. So I'm going to put 1 in that x, I'm going to put 1 in that x, and if I work that side out, it's going to give me y, right? And that's who I want, is y. Okay, so that's what we're going to do. We're going to put 1 in that x and 1 in that x. So I'm going to show all my work on this first one. I'm going to recopy the y equals, where the x is, I slap down parentheses. I'm going to plug the 1 in, put the squared on the outside, recopy the minus 2. Where the x is, I slap down parentheses again. I plug the 1 into it, and I recopy the minus 3. Now, we could either just do this in our heads, order of operation, or we could use the calculator. Are any of you opposed to using the calculator, or do you want to do it order of operations in our head? Okay, I'm going to suggest the calculator just because it will make things go a lot faster, but I could show you how we could do it without as well. So I'm going to put the parentheses, the 1, the squared, the minus 2, parentheses 1, and minus 3. And those are minus symbols, not negative symbols. So I just type it in the calculator like I wrote it on my paper, and the parentheses are very important, especially if you're plugging in a negative number. If you plug in a negative number and you don't use the parenthesis right there, you're going to miss it. and we get -4. Did everybody get that? Okay, so that's our y value. So the first thing I'm going to do is I'm going to go ahead and plot my vertex. So I'm going to go right 1 and down 4. And there's my vertex. Okay, if I was to do this order of operations, the first thing you would do would be the exponent. So what is 1 squared? 1. What's -2 times 1? -2. And then I'd recopy the -3. If you work that out, 1 minus 2 minus 3, what's 1 minus 2? And -1 minus 3 makes? So there you can get the -4, but without using a calculator. So if you had to work this out without a calculator, you just follow order of operations. You do the exponent first and then go from there. Okay, next thing we're going to find is our y-intercept. So I want to talk about y-intercepts for a second. Y-intercepts are always on the y-axis, and they have something in common besides being on the y-axis. Do you know what all y-intercepts have in common? The x is 0. Your x is a 0 because you're not right or left off of this axis. So no matter where you are on the y-axis, your x value is going to be a 0. If your x value is not a 0, you're not on the y-axis. Okay, so y-intercepts always have a 0 for the x. So all I'm going to do, have you guys ever hit second enter on your calculator? If you go second enter, it pops up the last thing you typed. And I'm just going to arrow back, and I'm going to put zeros in place of my x's this time. Do you know what you'd get without even hitting enter? Not 0. -3. Because 0 squared, 0. 0 times 2, 0. So all you'd have left is -3. Okay, so that's what we get when we plug in our 0. And then I'm going to plot him, and I'm going to flip him. So I plot 0, -3, so I don't go right, I don't go left, I just drop down the 3. And I'm going to flip him over the axis of symmetry. Do you know where he would land if you flipped him? Well, 0, -3 is what I just plotted. If you flip that over the axis of symmetry, 2 -3. You go right 1 to hop on the axis, right 1 more to get to his reflection point, and it'd be 2 -3. Okay, I want 5 points total on our parabolas. So we're just going to pick some other point. So when you pick another point, you want to pick an x value that's close to these 3 right here. So here your x is a 0, here your x is a 1, here your x is a 2. What's an x value close to 0, 1, and 2? 3. So we're going to pick an x value of 3. Sometimes I've had students say in the past, well, how do you know what to pick? You can pick whatever you want. But if you picked a 10, let's just say I picked a 10, and I put 10 in that x. What's 10 squared? 100. I'm not going to fit this on my graph. So the bigger you get, the less likely it is to fit on the graph. So if you pick something really close to your vertex and the other points you've plotted, more than likely it's going to fit on the graph. So we're just going to pick a 3. So the great thing about the calculator is I can just go second enter and just back it up and put 3s in place of the zeros, because I'm putting a 3 into all the x's now. And I get 3, 0. Okay, I'm going to plot that, and I'm going to flip him. So to plot 3, 0, I go right 3, and I don't go up, I don't go down. Can you tell me where that one would land if you flipped it over the axis of symmetry? -1, 0. Twice to the left, boop, boop, to hop on the axis. Twice more to the left, boop, boop, to get to his reflection point, and that's -1, 0. So you just go twice to the left to hop on it, twice more to the left to get to his reflection. And then you make the best U that you can. Try not to make it look like a V. So you want it to be U-shaped, not V-shaped. Because your V-shaped graphs, those are absolute value graphs, and those are the graphs that have the straight up and down bars surrounding the X, and we don't want that. So you want to try to make it as U-shaped as possible. Okay, I do want to practice domain and range because we've been working on that the last few days, so I just want to make sure that everybody's good with domain and range. So let's try domain real quick. Does this graph go forever to the left and forever to the right?
Yes.
So the domain's all real numbers. So I'm going to say X such that it's all real numbers. How do you write that in interval notation? Negative infinity to positive infinity. If it goes forever left, it's going to hit all your negative x's, and if you go forever right, it's going to hit all your positive x's. So that's negative infinity to positive. Okay, range is a little bit harder. So let's look at range. Range is about your y's. What's your lowest y you have? -4 is your lowest y. And then are your y's getting bigger than -4 or smaller than -4? Bigger. So I say y such that my y's are greater than or equal to -4. So y such that my y's are greater than or equal to -4. Can you tell me what that would be in interval notation without me telling you? Good. To infinity. So -4 gets the bracket because it's actually at the -4, and then it goes up, 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 up. So that's to positive infinity. And you can't get to infinity. That's why infinity always has the parentheses. Was that one fun?
Yes.
Oh, Tori, thank you. I am not feeling the enthusiasm from others. Okay, I'm going to skip to 2, where we have nothing written. And I'll just go back through what we're going to start off finding. We're going to find the axis of symmetry first. And the formula to do that is x equals opposite of b over 2 times a. So that's how we find our axis of symmetry. X equals opposite of b over 2 times a. Okay, which one's your b? -6 is your b. So what would you get if you took the opposite of b? A positive 6. Okay, which one's your a? 3. Your a is the number in front of the x squared, so your a is a 3. So if you took 2 times a, what would 2 times a give you? 6, and 6 divided by 6 makes? Okay, so our axis of symmetry is x equals 1. So let's go to where our x is a 1 and draw ourselves a dashed vertical line. And it's easier for me to see mine because I'm using markers. Okay, based off of what I said earlier, do you know, is this parabola going to open up or down? It's going to open up because the a is positive. Okay, next thing we find is our vertex. We already know something about him. Do you know what we know about him? It has a 1 for the x. Whatever you get for the axis of symmetry, that's also the x coordinate of the vertex. I just need to find Mr. Y. So, if this is the x, where am I going to put it in the problem? Where the x's are. Okay, so I'm not going to show it this time. I'm just going to go straight to my calculator. So, in the calculator, I'm going to type a 3. As soon as I see Mr. X, slap down parentheses. We're plugging a 1 in him. Close the parentheses square. Recopy -6. As soon as you see the x, slap the parentheses down, plug the 1 in. And you get -3. Okay, so I'm going to plot my vertex. So I'm going to go right 1 and down 3. And I'm going to go from there. Okay, next thing we do is we find our y-intercept. And a minute ago we talked about it. Y-intercepts always have a what for the what? A 0 for the x. Otherwise, you're not going to be on the y-axis. So I know the x value is a 0. I just need to find the y. So I need to put 0 in both of those x's. So if I use my calculator, I can go second enter and put 0 in place of those. Do you know what this is going to give you before you hit enter? 0. 0 squared, 0. 0 times 3 is 0. 0 times -6 is 0. There's nothing there. Just 0. Okay, so my y-intercept 0, 0. I'm going to plot him, and I'm going to flip him. Do you know where that one's going to land when you flip it over the axis of symmetry?
2, 0.
2, 0. 1 to the right to hop on it, 1 more to the right to get to his reflection point. So 2, 0. Very good. Okay, and then we're just going to pick one more point. So I want to pick some x that's close to these guys. So here your x is 1, here your x, here your x is 0, here your x is 1, here your x is 2. What's an x close by? We already have a 2. 3. Okay, so let's pick an x of 3. So if 3 is the x of your picking, then all you have to do is go second enter and replace what's in the parentheses with 3's. And if you do that, you get 9. We're going to plot it, and then we're going to flip him. So we're going to plot 3, 9. So I'm going to go right 3 and up to the 9. Do you know where that one's going to land when you flip him? Doot, 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 doot. Anybody?
9, 0, or 9, 0?
Twice to the left to hop on it. Beep, beep. Twice more to the left to get to his reflection. Beep, beep. and it's negative 1, 9. Right? Twice to the left to hop on the axis of symmetry, twice more to the left to get to his reflection point. Is that being a struggle for people?
No, it's pretty easy.
Okay, and then make your U. The skinnier it is, the harder it is to make it look like a U. Okay, take a second, and you guys try to do domain and range for me, just because we've been practicing that the last few days. So I want to see how you're doing with that. So take a moment, try your domain and range.
I know.
Oh, I could draw sticks. I didn't even think about it in my last class. Honey. Okay. Okay. Are we ready? All right. I'm going to start with domain. Oh, taking his final. Marisa, give me one way that you wrote domain. X such that. All real numbers. The graph goes forever to the left and forever to the right. So that's all real numbers. Beautiful. And then Spencer, what's the other way of writing domain?
Negative infinity.
Beautiful. So negative infinity to positive infinity. It hits all the negative x's when it goes to the left, and it hits all the positive x's when it goes to the right. Okay, range. Mariella! Y such that y is greater than or equal to negative 3. Your lowest y we have is a negative 3, and then the y's get bigger, 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 because they go up. Okay, and then the other way of writing that goes to Brooke. Negative 3 comma infinity. And the negative 3 is going to get a bracket, and the infinity will not. Because we can get to the negative 3, but we can't get to infinity. Very nice. All right, let's try number 3. So first thing I'm going to do is I'm going to find my axis of symmetry. And I use the formula x equals opposite of b over 2 times a. Okay, what would you get if you took the opposite of b? What kind of 4? A positive 4. Your b is a negative 4, so the opposite of negative 4 is a positive 4. Okay, how about 2 times a? 2. My a is a 1, and so 2 times 1 is 2. And what's 4 divided by 2? 2. So my axis of symmetry is x equals 2. So I'm going to go right to where my x is a 2 and draw myself a dashed vertical line. Now, do you know, is this graph going to open up or down?
It's going to open up.
It's going to open up because our a is a positive number. Okay, so all we've had so far are graphs that open up. All right, next thing up is finding the vertex. And I already know something about him. What do I know? The 2 is the x value. So whatever your axis of symmetry is, that's the x coordinate to your vertex. Okay, I want to see if you can find the y value without me saying a word. See if you can find the y value to the vertex without me talking about it. I used to always make my students do it by hand. Always. But we're almost at the end of the year, and I just kind of want you to get an understanding, so that's why I thought we'd use the calculators. And if anybody wants to see me do it without the calculator, I'd be happy to. Okay, let's see. Oh, Andy, do you have it? Oh, Josh isn't here. Macy, do you have it? It should be -9. So in the calculator, I would go slap the parentheses down, plug the 2 in, square it, minus 4, slap the parentheses down, plug the 2 in it, minus 5, and you do get negative 9. Does anybody want me to do it by hand, like without the calculator? Okay, so let's plot our vertex. I'm going to go right 2, and I'm going to go down 9. Okay, after we find our vertex, the next thing I want to find is our y-intercept. And y-intercepts always have a what for the what? A 0 for the x. Otherwise, you will not be on the y-axis. Okay, so I'm going to put zeros into all my x's this time. So I can just go second enter, back it up, put in a 0, back it up, put in a 0. Do you know what it's going to be before I hit that enter?
0.
Mm-mm. This one I would expect everybody to be able to do in their head just like that. Negative 5. 0 squared is 0. 0 times negative 4 is 0. So all you have is 0 minus 5. And it would be negative 5. Okay, I'm going to plot him and flip him. So to plot the 0, negative 5, I don't go right, I don't go left, I just drop down to the negative 5. Where would this one land when you flip him?
4, negative 5.
Good, 4, negative 5. Twice to the right, boop, boop, to hop on the axis. Twice more to the right, boop, boop, to get to his reflection. Okay, this time when I go to pick my other point, I've got an x value of a 0, an x value of a 2, an x value of a 4. What else would be close? 1 would be close, 3 would be close, 5's not too bad, getting farther away than I want. Negative 1's not too bad, getting farther away from the vertex than I want, but 1 would be good and 3 would be good. So I'm just going to do the 1. So the great thing about the calculator is I can second enter, back it up, put 1's in, and when I put the 1's in, I get negative 8. So I'm going to plot my 1, negative 8. So right 1, drop him 8. Where would this one land when you flip him? 3, negative 8. Right 1 to hop on the axis, right 1 more to get to his reflection, which is 3, negative 8. And then now that you have your 5 points, you can make your pretty little U. I find the sounds make better looking U's than the lack of sounds. All right, try domain and range again, and then I'm going to draw some more sticks.
You have an exam.
Yeah.
What are we doing? What are we doing?
Do you know how much I really want to hurt the two of you right now? Because I was very clear at the beginning of class what we were doing for the next several days.
I heard that you said this was our last.
I did say this was the last lesson of the year. What else did I say? Okay, so far you can see on my board. Wednesday, teaching the lesson, last lesson of the year. Woo! Tomorrow we're doing whiteboards over what I'm teaching today. Friday I told you I'm not going to be here because I'm going to my daughter's end of year party and her award ceremony. So I'm going to let you guys start working on the review for the final tomorrow and watch Big Hero 6 while you're watching it. And then Monday, you can work more on the review and finish Big Hero 6. And then Tuesday, Wednesday, we'll work more on the review. And then exams are Thursday, Friday. Yeah, tomorrow we're just doing whiteboards over this. Okay, domain goes to, Blaze. Hi.
Take him out. Why do you keep saying that? Take him out.
Well, I think that's the first time I've drawn him since he's left. Did I? Are you sure? Julia, what'd you get for your domain, hun? Such that. All real numbers. Good. Okay, let me draw another stick. Robert, the interval notation for domain? Good. Negative infinity to infinity. Beautiful. Okay, range goes to, Brady. Tips? Range?
Y,
Such that.
such that y greater than or equal to -9.
Y such that y is greater than or equal to -9. Very good. -9 is the lowest y, and then they go up, 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 so the y's are getting bigger. Very nice. And then interval notation, Cody Taylor.
Parentheses -9, comma, infinity, positive.
I love it, except for the -9 gets a bracket because you actually are at the -9, but infinity you can't get to, so it gets the parenthesis. All right, we're going to do one more and call it a day. I want to go to number 5. Am I really killing you, Jonathan?
No. I love you.
All right, you tell me. What's the first thing we find?
It's a negative.
Good. The axis of symmetry. And it has a special formula, x equals, do you remember? Okay, opposite of b over 2 times a. Very nice. All right, so what would you say the opposite of b is? It's a positive 12. Okay, and then how about 2 times a? Negative 12, because it's 2 times -6, so that's negative 12. And then what's 12 divided by negative 12? Okay, so there's our axis of symmetry. X equals -1. So I'm going to go left to where my x is a -1 and draw myself a dashed vertical line. Now, is this parabola going to open up or down? He's going to open down because our a is negative this time. Okay, so this is our first down opening parabola today. All right, after I find the axis of symmetry, what's the next thing we find? The vertex. Beautiful. And what do we know about him? Yes, the -1 is the x value. Axis of symmetry and the x coordinate of the vertex are always the same. Okay, I want to see if you can plug that in and find me the y. And I will draw a stick. And it goes to Ian. What, hon? It shouldn't be that. Tristan? Tori?
I have an EMF.
Oh, you don't even have a calculator. Ryan?
5.
It is 5. In the calculator, I just type it in the way you see here. -6, slap down the parentheses. We're plugging the -1 in, square it. -12, slap the parentheses down, -1, and then -1. And you should get a 5. Does anybody need to see me do this? Order of operations, no calculator. Okay. So I'm going to plot them. I'm going to go left 1 and up 5. Now you already told me the parabola is going to open down, so we kind of have an idea of what it might look like. Okay, what's the next thing we find after we find the vertex? Good, the y-intercept. And the y-intercept always has a 0 for the x. Okay, so let's plug zeros into those x's. So I'm just going to go second enter, back it up, plug in a 0. I will have to delete. Plug in a 0. I will have to delete. Can you tell me what that would be without me hitting enter? -1. And that's what you should get. All right, so I'm going to plot my y-intercept, 0, -1, and I'm going to flip him. Where would he land if you flip him? -2, -1. Once to the left to hop on the axis, once more to the left to get to his reflection. Okay, I just need to pick some other point. So you want to pick an x value that's close to these x values. So here your x is -2, here your x is -1, here your x is 0. What's an x that's close? 3 is a little farther away than I thought you might pick. 1. 1 is closer, and -3 is closer. But you get farther away, like 3 is farther away than I was hoping you guys would get. So let's pick a 1. The farther away you get from the vertex and the other points, the more likely it is to not fit on the graph. Okay, so I'm going to second enter, and I'm going to back it up, plug in a 1, back it up, plug in the 1, and if I do that, I get -19. Here's a -19, Ian. Did you accidentally plug in a +1 instead of a -1? Okay, so we're going to go right 1 and down 19. And that doesn't even fit. So I'm just going to estimate it. He's down here somewhere. Boop, 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 boop. Something like that. So that one doesn't even fit. But that's okay. We know what he is, and then we just make the best U that we can. Chicka, 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 chicka. Do you see how skinny he is? Somewhere you guys would have learned that the bigger the A, the skinnier the graph, the more narrow the graph, the more compressed the graph. The bigger the A is, the skinnier it is. The smaller the A, the wider the graph is. Okay, what would you say? Let's just do domain and range real quick. What would you say the domain is? X such that all real numbers, because the graph goes forever left, forever right. How about interval notation? Negative infinity to positive. Good, because it hits all the negative x's, all the positive x's. Okay, range y such that y is less than or equal to 5. 5's your highest y, and then they go down, 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 so the y's get smaller. Okay, how about interval notation? To 5. Beautiful. Negative infinity to 5. Very nice. All right, let's give it a giant smiley face. Woo! Last lesson of the year. There he is. Tomorrow, whiteboards. Friday, work on review for the final. That's that. To the test. I started taking it this morning, but I haven't finished it.